Thank you. Thank you very much. I know you have a choice of picking lots of other sessions, but I'm glad you picked mine. So thank you very much. People ask me about what is this mustache for. This mustache is Mustache November or Movember. It's a statement for saying that too many men are dying young. So as much as women's health is important, men's health is equally important as well. So make sure you rest enough. Make sure you eat healthy. Make sure you work out regularly. Particularly for programmers, our lifestyle is very sedentary. So if there is a man in your life, yourself, your dad, your father, your partner, your brother, encourage them to live healthy. So that's sort of my 30 seconds of message that I want to tell everybody. Let's get back to real life. So this talk is going to be about Kubernetes-izing your Java application. I'm a Java developer, been a Java developer for many, many years, actually. I joined Sun Microsystems back when we were releasing JDK 1.2. As a Java developer, what is it that I need to do to Kubernetes-ize my application? My boss comes into my room, hey, this new thing Kubernetes comes up, package this application and deploy it into a Kubernetes architecture. So what do I do? So this is sort of my journey on how I see sort of the flow looking like. This is open source GitHub repo on AWS samples, Kubernetes for Java developers. So the name is very intuitive in that sense. Everything I'm going to do, there are absolutely no slides, is going to be walked through this GitHub repo, essentially. So if you look at the table of contents here, I'm going to quickly walk through what my basic application is. The application is by purpose, very simple. It's just a Spring Boot application that returns hello world. That's it. That's all it does. And you can mimic your complex Java application from it if you want to. Then I'll talk about the journey on how we go through Kubernetes-izing your Java application. What does it require to Docker package your application? What are my different options as a Java developer? What do I need to do to create a Kubernetes manifest around it? And how do I deploy my entire thing as an application? Then we talk about a little bit of, as a Java developer, I'm used to tools like IntelliJ, Eclipse, NetBeans, debugging my application. How do I bring those paradigms, as I'm Kubernetes-izing my application, essentially? We'll talk about, particularly from Java perspective, and when you are creating microservices-based application, you really need to trim down your image size. So we'll pay a little bit special attention to how do we trim the image size over there, particularly with features starting with JDK 11 onwards, or 9 onwards, actually, but now 11, essentially. We'll talk about how do you migrate your application from dev to staging to prod, or those different stages. We'll talk a little bit about how do you create a Kubernetes cluster on AWS for that. And then we'll, depending upon the time towards the end, we'll talk a little bit about your cross-cutting concerns like monitoring, metrics, logging, canary deployments, A/B, blue-green, whatever name you call it as. So we'll talk a little bit about that. And then the last thing would be, of course, a little bit about running a deployment pipeline. Not just on your local laptop, where I can see quick feedback, but possibly running it on the cloud as well. Okay? So this is pretty much the flow of the repo here as well. And I'm just going to literally walk through one by one. Copy-paste the code. That should really work. If it doesn't work, that's a problem. So more than encouraged to you to file issues, send pull requests, any way that you can contribute. Everything is welcome, essentially. So my application is pretty simple. It's a simple Spring Boot application. So I'm going to fire up my IntelliJ here. While it comes up, it's a Spring Boot application. All it does is it returns a simple hello. So host, port, and /hello. Okay? Let me walk you through the application here. So here is my greeting controller. And as you can see, it's a simple Spring Boot application, just returns hello. So nothing fancy in there. If you look at, say, pom.xml, it's again a standard POM XML here. I'm using Spring Boot Start or Web. I have a Spring Boot Maven plugin that allows me to run the application in my console. And I have a Jib Maven plugin here that I'll talk about a little bit later. And that's in a separate profile. So ignore that profile for a second. But for all practical purpose, this is a very standard Java application the way you will start with. So now I'm going to go into my console here. Well, first of all, if I go back to the repo here, The source code is in the app directory. So you look at app, and that's where all my source code is over there. And that's the directory that I showed in IntelliJ as well. Okay, so I'm in the app directory, which is Kubernetes for Java developers, app, and all I'm going to say is Maven Spring Boot :run. Okay, so let's kind of see what my application behavior looks like to begin with at least. So it fires up my application, downloads the internet if it needs to, and then I'm going to say curl. Well, the application is running locally on port 8080, and hello is the URL for the application. If I do this, it just returns a response, hello. Very simple, very clean response. And the application is intentionally very simple, because the whole point is to show the journey from there onwards. You are the subject matter experts for how your application looks like. So let's go back here for a second and terminate my application so that I can free up my port here. Okay? So that's a very simple step here. The next thing I want to do is I want to start converting this image, a Java image, into a Docker package now, or Docker image now. Okay? So how do I take that? What are my different options? Well, I can there are tools called as Docker Maven plugin or Gradle Maven or Docker Gradle plugin. Those are the plugins that plug into your POM XML. And you can tie the phase and the goal together. So even if you say Maven package, as part of the Maven package, it will invoke that particular goal. Like in case of a Docker Maven plugin, it will build the Docker image, and it will generate the Docker image as part of your application itself. So you say Maven package, and if you specify a profile, depending upon if it's specified in the profile or in the main POM XML, you can generate a Docker image right there itself. Similarly works for Gradle as well. Well, that's one approach. The other approach that I've seen customers using all the time is, actually a few weeks ago rather, I ran a survey. I asked, how do developers prefer to generate their Docker image? There's a Docker plugin, there's a Gradle plugin, there's a Docker file, which is sort of the standard syntax that Docker provides on how you create your Docker images. By overwhelming majority, I would say pretty much 70% of the developers that I surveyed, and there were about 400 plus votes to that survey. So there were about 70% of developers said they use Dockerfile. So let's take a look at Dockerfile and essentially what we can do over there. So if I look at my Dockerfile here, so here I am. Let me close these here. So here's my Dockerfile. Now, the way Dockerfile looks like is, it has a bunch of instructions in there. The very first statement in a Dockerfile is typically a from line, which says, OK, here's my base image. So I'm going to start with the base image. And then on that base operating system, I'm going to build my application. Now, in this case, I'm using Maven 3.5 JDK 8 on very line first. That is sort of my base image over there. Why is that relevant? Well, that is relevant because if I can literally give this Docker file to any other machine. I don't need any other third-party tools to be installed over there. Because now I'm using Maven as the base image itself. So I could literally say Docker image build, and it'll download the base image, which includes Maven tooling as part of that itself. So it kind of allows me to package my dependencies of my application, independent of runtime, also build time as part of the Docker file itself. So it can easily package it in there. Now, one of the typical ways is that you will, if you run it, every time you run it, because the way Docker provides the image layering, it would download the Maven artifacts all the time. So that could really bloat up your build time, essentially. So one of the ways that I've seen people doing is where they can say, create a Maven repository, in my case, m2.tar.gz. So I've created a clean Maven repository, and then I can just copy that Maven repository into the file system of the image itself. And the difference here is it's called as add. The next command is copy. Well, what add does it takes m2.tar.gz and it automatically expands into the root directory. What copy does is it just does a copy. It doesn't really expand anything. So depending upon how you're structuring your Docker file, you can start leveraging it accordingly. Now I have my Maven dependencies copied in there. Then I'm saying Maven, use the POM XML coming from the app directory and do the clean package. So clean and simple. That allows me to build it. Now, typically, your Docker file will have a single from statement. This one has 2 from statements, and that's called as a multi-stage Docker file. And what's happening here is on line 1, essentially, I'm saying, here is my first stage, and the name is called as build. My second stage really starts from line 8. And there I'm saying, oh, use the OpenJDK 8:8-JRE image. Okay? One of the big design patterns, rather anti-patterns that I've seen is customers will build their Java applications, and they'll use OpenJDK as the base image. Or, I mean, OpenJDK is just one distribution, essentially, but they'll use JDK as a base image. Do you really need JDK as a base image? So my point here is, instead of using JDK as a base image, try to use JRE as a base image, because if you are only packaging a runtime artifact, which is your jar file, all you need is just a JRE. You don't need the entire development kit over there, essentially. And that could significantly reduce the size of your Docker image itself. So that's a big difference in terms of size. And it's very relevant, particularly in a microservices world, because your image could be dynamically downloaded on any host at any point of time. So you want to make sure your image size kind of stays lean and clean in that sense. All right, so in my second stage, I'm using JRE as a base image. I'm exposing certain ports. All I'm doing is, from the build stage, I'm copying the target directory into my second stage. Now remember, in the first stage, I have m2tar.gz, all the class files, etc., generated over there. I don't need that as part of my Docker image. So I'm explicitly copying the generated target jar file into my second stage. I set up the work there, set up some Java options. These are useful for me when I'm debugging my applications later, and then I just fire up the application. So a couple of important points here, using multi-stage file. First stage for building, discarding everything from the first stage, just picking the jar file, copying it into the second stage, and in the second stage particularly, again, using JRE as a base image, not JDK. So that's an important aspect. Okay, so that's sort of the command that we can use over here. I can literally copy this command here. And if I go to my console here, I can just say Docker image build. I give it a tag, in this case, Arun Gupta /greeting, and I say dot. It takes dot as the current context. And of course, I don't have m2.tar.gz. So I won't spend time on creating m2.tar.gz, but there are instructions essentially on how you can create m2.tar.gz here. So I can say, Maven, create a clean m2.tar.gz for me. But once I have m2.tar.gz, then I can just create a Docker image out of it very conveniently. So that's one way of creating Docker. That's the second way of creating Docker image, actually. We talked about Docker Maven plugin, multi-stage Docker file. And then the third tool that is done by the Google Container team as well is Jib. Jib is, again, plugged in as a Docker Maven plugin. And it has certain advantages that are very relevant, particularly for Java developers. Because, first of all, it doesn't need a Docker daemon. So in my case, like Docker Maven plugin or Docker file, it always talks to a Docker daemon or Docker engine running on my local host or somewhere, whatever my Docker client is configured to. Java developers may not have a Docker daemon in that sense. So that's where Jib tool works very handy. It doesn't need a Docker daemon. Second thing is, if you look at Docker files, sometimes the files could be really scary, on how complex the Docker file could be, even though the whole intention and design was to keep it simple. But Docker files could be really hard sometimes to write. So in that sense, if you are a pom.xml programmer, if you like the format over there, it just allows you to write everything in the pom.xml format over there. And the third part, which is actually, or the fourth part, rather, which is very, very relevant, is if you understand how the images are layered, if you take a look at a Docker image, is essentially a bunch of layers. The very first layer is the base operating system. Then top of that, then you have a JDK. Then you have your application, and so on and so forth. But now, in a Maven world or in a Java world, if you're building a Spring Boot application, what is the part that changes the most? The part that changes the most is your application, not your snapshot dependencies or your other jar file dependencies. So essentially, what Jib does is it provides a huge advantage. It creates those layers where there is a layer for jar dependencies, there's a layer for snapshot dependencies, and there is a layer for your application classes only. So essentially, when you are building the image, it's only rewriting that application class layer. Those other dependencies, if they are not changed, it identifies them, and it keeps it exactly alike. What that means is, now when you're pushing the image is again pushed to the Docker Hub repo as a set of layers. So when you're pushing the image as well, you're not pushing like a 100 megabyte image. You're pushing only your application classes, which are typically in a few kilobytes fragment as well. So I think that's a very big advantage of Jib, essentially. So I've seen customers using Docker Maven plugin, Dockerfile, and Jib in all possible cases. So see, there is no golden hammer here. See what works for you and see, and then how you can actually create an image for yourself. Now, if I take a look at it here, so what I can do is, in my IntelliJ, essentially, I can go to the profile that we were hiding earlier. Here is a Jib Maven plugin. I'm using version 0.9.13. All I want to specify is I just want to use OpenJDK 8 JRE as my base image, as I was doing in my Docker file, essentially. I just give it a Docker image. I specify my options, the ports I want to expose, and I tie the package to the build phase. So now I can go back here in my terminal, essentially. I can say Maven compile Jib Docker build -p-jib, and this is going to use the Jib Maven plugin and build my Docker image as well. And then when I look at the history of the image, it will show you exactly how the layering is being done. Now, this is a sort of a bug in the Jib itself, because it's saying retrieving registry credentials for registry-hub.docker.com. If it's not building to the local Docker engine, what it's doing is it's actually building the image, but it's pushing the image to the Docker Hub directly. So the Jib plugin, I filed a bug on this. They need to provide a little bit more active feedback on it. But until then, what it's really doing is right now pushing the image directly using the conference Wi-Fi to my Docker Hub. So we'll wait for it to complete, and then we'll come back to it, essentially. Now, let's say if your image is up and running. What I want to do is I created my Docker image. I can copy this command here. So let me fire it up in my terminal here, or actually open up a new terminal here. So all I'm going to do is I want to run that container now. My Java application is packaged as a Docker image now. I'm saying Docker container run. I'm giving it a name greeting. I'm doing the port forwarding, 8080 on the local host to 8080 in the container. And I'm running it in a detached mode, so in a background container. And then I'm using this particular image. So if I fire it up, it's going to run my container here, okay? And now I can say Docker container logs, and my name is greeting. So it'll show me the container logs, essentially. And the same logs that were shown in my console for my Java application are now visible using my Docker image itself. So now I can give the same command here. If we go back here, I can say curl http localhost 8080 hello. I'm getting the exact same response, but this time, now that response is actually coming from Docker image. So first step is get your Java application up and running. Second step is to package your Java application as a Docker image. Make sure you're actually getting the exact same results, okay? So what I'm going to do is I'm going to go back here to my container. The logs look good. So I'm going to just remove the container to free up the port here. So there goes my container away. So as I terminate my application, my Docker container goes away as well. So what is sort of my, now if I look at here, for example, Docker image ls grep greeting. I do have a lot of greetings over here. But if I look at, say, Arun Gupta /greeting and say latest image here, okay? If I look at the latest image, this is about 490 megabytes. Now, if I look at, say, Docker image history, Arun Gupta /greeting, if I look at this greeting here, here is my base image here, which is about 100 megabytes. Then apt-get, apt-install, installing some packages over here. Here comes all of my JDK, about 309 megabytes. And here is my application here itself, 46.8 megabytes. So overall, it does become quite bulky. Now, imagine on the fly, you're scaling your microservices up and down, and this 490 megabytes of image needs to be downloaded on a host on the fly. That basically adds to your service scaling time. That's where it's super critical that you keep your image size really small. Now, JDK 9 introduced the concept of modularity. So you can really, what they've done is they've taken the JDK and they've split it into multiple modules, and your application could be one of the modules. And for example, if you're writing a Spring Boot application, you don't really need like a Corba or AWT or Swing kind of modules. That's an important aspect, okay? So what you can do here is you can use JDK 11, which is sort of the latest JDK from Oracle, essentially. And you can create a custom JRE. You don't need the full-blown JRE. You can create a custom JRE very easily. And for that, we essentially use two tools, JLink and JDeps. Okay, so let's see how we're going to use those tools. Well, the first tool that we're going to use is called as JDeps. JDeps is a tool package in JDK itself. And all we are saying is that, OK, JDeps print the module dependencies for my app.jar file. Okay, that's the jar file that is generated from Spring Boot application. And Spring Boot by itself is not modular. So I have to specify all the modules that Spring Boot really depends upon. And this is a list of modules that it depends upon. But essentially, I'm handpicking the modules that are really needed for my Spring Boot application. And then if my application has any dependencies. So those are the only modules. That's essentially the role of JDeps, is to give me the list of modules that the application depends upon. And then I'm using the tool called as JLink. With JLink, I'm saying, create a custom JRE for me by adding all these modules. Now, what I get is a custom JRE, which is exactly tuned for my application, as opposed to the full-blown JRE, which I don't really care about. If you take a look at the Docker file here for that, so I have dockerfile.jre. So all I'm doing is, instead of using Maven, Apache Maven as a base image or OpenJDK JRE as a base image, I'm using Debian 9 Slim. I generated my custom JRE. And then in that custom JRE is my VM. So I'm using my JRE bin/Java to fire up my Docker image, essentially, or my Java application. Well, what is the size difference? Essentially, what you see here is huge, actually. My regular image was 490 megabytes. The image that I generated using custom JRE is 162 megabytes. So that's literally less than 1/3 the size of my regular image. So would recommend taking a look at it if you can really fine-tune the size of your Docker image by using custom JRE. All right, so second step is essentially creating a Docker image out of my Java application, and then making sure that application continues to work, whether you're using Docker Maven plugin, Dockerfile, Jib, whatever tool you're using to package the application. But now the third step is really to write a Kubernetes manifest for that application, essentially. So what I'm going to do is I need a Kubernetes cluster for my machine. There are a couple of options for that. The first one that has been prevalent for a long time is Minikube. So people download Minikube that gives you a single node Kubernetes cluster on your machine, but you can get very easily started with that. Now, the other option is if you do have Docker Engine on your machine. So for example, this is a MacBook, and on MacBook I have Docker for Mac installed. So if you see on the top here, you can see it, yeah. I can click on Preferences. Later. In Docker for Mac, I'm seeing this Kubernetes tab, essentially. Now, Docker used to have only Docker Swarm as an orchestration engine. It has Kubernetes baked into the latest version of Docker itself. So you can say, you know what, enable Kubernetes as part of my cluster itself, of my Docker for Mac itself. And what it gives you is, again, a single node cluster. So to me, I mean, I've not used Minikube for several months now. If I need a single node Kubernetes cluster, I just literally click on enable Kubernetes here, apply, and that's it. And here you can see it's showing you Docker is running and Kubernetes is running. So I can very easily get started with a single node Kubernetes cluster if I have the Docker for Mac or whatever your local Docker version is. Once you create a Kubernetes cluster, then the idea is that now I need to take that Docker image and convert it into a Kubernetes manifest, and then deploy that application. Think of your application. Your application has typically multiple components, and then each component will have to have a Kubernetes manifest. So for the first time, it's good to start with a Kubernetes manifest that, OK, I'm going to write a Kubernetes service or a Kubernetes deployment, and then I'm going to create that manifest. But then pretty soon, you start having multiple services and multiple deployments, and then it becomes a challenge that how do I really start deploying multiple of those objects together? How do I bring consistency across multiple of those objects? And that's sort of the challenge that you have to face. That's where Helm charts comes in handy. So Helm charts is an abstraction on top of multiple Kubernetes manifests, which basically defines how a Kubernetes application should look like. So you have a Kubernetes application defined as a Helm chart which has multiple manifests in there. So let's take a look at it, what my manifest could potentially look like. Okay. Well, let's go here, actually. So I'm going to go to my manifest directory here. In manifest, I have a my app directory. Well, let's take a look at a simple manifest first of all. Here is a typical Kubernetes manifest. I'm saying this is apps/v1 API. I'm defining deployment manifest here, deployment object, which is a standard Kubernetes object on how you create a deployment in Kubernetes. This deployment has some metadata. I'm saying I want a single replica of this particular deployment. I define certain match labels, which we'll get to in a second. But then in the deployment, what I have is a pod, which is a first-class Kubernetes concept. And pod is the lowest Kubernetes object that you can create by yourself, essentially. And pod will have like one or more containers. Now, containers is a part that we just learned about as part of creating a Docker image. So that's exactly sort of my intersection point over there. Now, if I go back to my manifest here, so I have a deployment, I have a replica, I have metadata here. And then in the pod spec, which is called as a pod spec, essentially, I can define my containers. And this is sort of my image that I just created. So once you have your Java application ready, created a Docker image, pushed to a Docker hub, then you can put it into a Kubernetes manifest just like this, exactly as shown over here. Okay? And once again here, I'm exposing my ports here, 8080 for HTTP. Now, what this deployment will create is a pod. Each pod is given an IP address. And that IP address is ephemeral. What that means is a pod, if it's terminated on a machine, and if it's started on a different machine, will maybe given a different IP address. But you want to have some means to be able to refer to that pod. So IP address is not the way by which you will refer it. So what you do is you really create a Kubernetes service. So what I'm doing here is I'm creating a Kubernetes service here. And in this, I'm saying in my service specification, essentially, I'm saying selector is app:greeting. And what app:greeting is a name-value pair that is attached to any Kubernetes pod. So if I go back to my pod spec here, in my pod spec, I'm attaching the metadata here. And in the metadata, I'm saying the labels are app:greeting. So now think of it this way. You create a Kubernetes deployment with a single replica of the pod with a particular label, app:greeting. And then you create a Kubernetes service, and the service says, oh, give me a pod that has that particular label. It doesn't know who is creating that pod, but it's a loosely coupled architecture, essentially. Anybody can create that pod, but it's highly recommended that your service and deployment are kind of coupled together, essentially. And then in the service, again, I'm saying, what are the ports I need to expose? If I say type::load balancer, and now if this service is deployed on a cloud provider, it uses the cloud provider specific load balancer. So for example, if you deploy this service on AWS, it'll basically create an instance of Elastic Load Balancer for you. Okay? So from developer perspective, the way it works is you create a deployment, you create a service if you want a referenceable name to all the pods, and then behind the scene, your number of replicas for the deployment can scale up and down. But your referenceable name stays exactly same. And there are multiple ways by which those number of replicas can go up and down. Now you can set up health metrics, you can set up thresholds, CPU memory thresholds based upon which the replicas can automatically go up and down, or you can manually scale them up and down. And there are ways and mechanisms in Kubernetes to scale those itself, truly in an upstream way. As we were talking, this is literally done for one service. Your application is typically not just one service application. It is multiple services. So you'll have deployments and service for pretty much all the services. And that's exactly the role that is played very well by a Kubernetes Helm chart. So let's go back here. Take a look at, say, my app. So this is in the manifest directory, my app. And here I'm seeing sort of how my application really looks like. Okay? So let's take a look at chart.yaml first. This is sort of the metadata about the chart itself, version, et cetera, that you want to specify here. Then I have a values.yaml. This is where I specify all sort of the hard coding of my different image types, my ports, my number of replicas, all that information can be specified over here. Because essentially what Helm charts are they are templatized Kubernetes manifest. So if I look at, say, templates now, I look at greeting deployment, for example. Now in greeting deployment, I'm still saying, so v1 beta 1 API is a deployment object. But now I'm using release.name, which is a name value pair that comes from values.yaml. Okay? I can start defining what labels are needed. I can start putting up replica count. So similarly, if I look at my service here, service again has release name, labels, external port, internal port. So what this gives me is the ability to specify all my constraints or hard coding of the values into values.yaml itself, and then repurpose them over here. So I'm truly following the dry principle of don't repeat yourself. Okay? And it also brings a lot of consistency to if I'm using multiple services and deployments across my application. So now I have my Kubernetes cluster. Let's take a look at that first of all. So kubectl is the CLI. You just download the CLI from, you can find the link for it from kubernetes.io, or you can install it, brew install as well. But once you have the kubectl CLI, then you can say kubectl config get context. And what it's telling me is that, okay, show me all the, like, typically you will have is a multiple Kubernetes clusters created, and at a given point of time, you will configure your kubectl CLI, which is a CLI to manage your Kubernetes cluster. So you will configure the kubectl CLI to talk to one of the Kubernetes clusters. And how do you identify which of the Kubernetes cluster is talking to? So you say kubectl config get context. It shows the context of all the clusters that has been created for you. So in this case, I have an EKS cluster and a Docker for desktop cluster. Now, Docker for desktop cluster is the one that we created using Docker for desktop. So if I need to change my context, so I can just say kubectl config use context, and I can say Docker for desktop here. And by default, it was showing me star on this particular namespace, or this particular cluster name. That means my kubectl CLI, any command that I give to kubectl CLI will be redirected to that particular cluster. But now I changed it. So let's look at get context again. Now the star has come to Docker for desktop. So basically what I'm doing is I'm simply switching what my kubectl CLI is going to be talking to. Is it talking to my local Kubernetes cluster, or is it talking to my Kubernetes cluster that is running elsewhere? In this case, it happens to be running on the AWS cloud. All right, let's go back here. So what I've done is I have a Kubernetes cluster. I have kubectl CLI configured to talk to the right Kubernetes cluster. Now I need to install Helm into my Kubernetes cluster as well. At least Helm version 2.0 has a client-server architecture. So again, you need to say brew install Helm CLI. So you get the Helm CLI here. And then once your kubectl CLI is configured to talk to a particular Kubernetes cluster, you say Helm init. So it installs a server-side component in your Kubernetes cluster as well. So you have your Helm CLI as well configured, kubectl CLI configured. You have your Helm chart ready to go. Now you're finally ready to deploy your application. Okay? So what we're going to do essentially here is I am just going to say Helm install, give it an application name, and manifest/myapp is where my chart exists. So I'm going to take that command here. All I'm going to do is Helm install, give it an app name, and chart directory. Well, the app already exists. So what we're going to do is we're going to say delete my app, and we will purge it as well. And let's deploy it again. So this takes my Helm chart, which consists of multiple Kubernetes manifests, and it creates all the deployment and services. Important part to understand is it does deploy all the artifacts together. It does allow you to delete all the artifacts together. But at runtime, how do these artifacts really correlate with each other is completely application's responsibility. Okay? So now in this case, for example, it's saying, all right, it's creating my app greeting. This is my deployment here. These are the pods here. These are my service here. So what I can say, kubectl get deployments. Okay, so it will show me a deployment, and it says one desired pod, one is current, one is up to date, one is available. There could be, depending upon how frequently your app is changing, how frequently you are scaling up and down your deployment, these numbers could differ. I could say service, so it's showing me the service here. And in case of service, it's saying that because you said load balancer as external, and I recognize, yeah, it's not a cloud provider, but I'm deploying my service on the local host, so I'm going to expose your service on local host here, essentially. Okay? And once again, the port here is 80, which is a mapping to 30258 on my container in there. So what I can do here is now, let's see if we can give this command here. So now I'm getting the exact same result from my Kubernetes application. So the point that I'm trying to say here is you start with a Java application, package it as a Docker container, get the exact same result from the Docker container, package it as a Kubernetes manifest, Helm chart, and get the exact same result. So you continue to make sure that your application is continuing to progress in the same direction. Now, what I can also do is I can go to my IntelliJ here. I already set up a breakpoint over here. Now I can say run, and I can go to debug. Okay? I have a profile already created, but essentially what I need to do is I need to create a remote profile here. And once I create a remote profile, these are the instructions that are shown to me out of default. And it says that, OK, take this command here. So copy paste this command, and this is the command that we had in our Docker file, because that's sort of where my JVM is interacting. So I take this command, put it into my Docker file, essentially. And it says, now my VM is listening on localhost and port 5005. Okay? So let's debug this here. So my IntelliJ is now connected and waiting for somebody to invoke on localhost :5005. So I go back to my terminal here. Let's invoke this thing again. And as soon as I invoke it, it switches to my IntelliJ. Now, if this were a little bit more detailed function, then you'll see all your class variables, everything, and you can start debugging it through. The point being, whatever tools that you have been using in your Java application development, those are all completely and still very relevant in the Kubernetes land as well. And I'm showing you this for Kubernetes, but you could certainly do the debugging at an earlier stage as if you were doing debugging the Docker container itself. Okay? So now, in this case, of course, if I look at this, it says class has no fields, so it's not showing me any values here. But what I can do is I can just say, go ahead, run it, and I get my result back, hello. I've never been so happy to see hello in my life 3 times in a row. All right, so we got that part covered. And by the way, all of these instructions are fully detailed on the GitHub repo. So in case you want to follow along, literally copy paste would work. I'm very lazy programmer. I don't remember things. I just put it into the GitHub repo and then let the GitHub repo reminds me back. All right, so now I have been able to test my application on a local cluster. My next step is really that, OK, I've tested this thing on a single node cluster here on my local machine. I'm ready to go to the cloud. So that means I need to run my Kubernetes cluster in the cloud. Well, you can definitely choose a cloud provider of your choice. We certainly hope it is Amazon. So if you're running, if you want to run Kubernetes cluster on AWS, there are a variety of choices. A lot of our customers use kops, which is a community-provided tool by which you can create a Kubernetes cluster on AWS. Or if you don't want to go through the heavy lifting of creating and managing a Kubernetes cluster by yourself, you can certainly use Amazon EKS. This is a managed Kubernetes cluster. This is a service that we announced at reInvent 2017. And a lot of our customers are loving it. So they literally all you do is you go to the AWS console and you say create a Kubernetes cluster, and voila, you get a Kubernetes cluster. What you get is a highly managed or highly available, fully managed control plane. You still have to attach the data plane to it. Those are the nodes where the containers are running, essentially. But it's a pretty straightforward process and well documented. Now, in my case, but though, again, as I said, I'm very lazy, so I don't want to go through the process of doing this through it's fun when you're doing it for the first time, in the console. Oh, I click on it, I wait for it. But the second time, it becomes like, oh, it's very repetitive, it's very boring. So I always like to automate things. So that's where this tool called as EKS Cuttle, very much like kubectl, is like EKS Cuttle. that creates an EKS cluster for you. And EKS is a tool created by one of our partners, Weaveworks. So really huge props to them. So essentially what you do is you create the EKS tool, and with this single command, you can just say EKS create cluster, give it a cluster name. I need 4 nodes and in this particular region, and that's it. That command really creates the entire EKS cluster for you. Highly available, fully managed control plane. It also creates a data plane and attaches those to the data control plane, and your cluster is ready in a few minutes, basically. Okay. Now, if I go back here, if you remember, our kubectl is configured for local desktop here. So I can say kubectl get nodes. It says, oh, there is a single node over here. So now I can switch the context here. So I can say get context. And I can say use context. And I can switch it. I mean, I have a EKS cluster pre-created. So I can switch it to this my EKS cluster. Now, if I say get nodes, this is basically showing a 4-node cluster that is already created on US West 2. Okay? So what does it take to switch your app from development to a test staging environment in the cloud or even a production environment in the cloud? So a lot of our customers, the way they do this is they literally switch their context from one cluster to another cluster and redeploy the entire application. And the important part over there is literally redeploy the entire application, because all you have is the Docker image is the source of the truth. So your Java application, then the Docker image, and that's exactly the source of artifact that is being deployed across different clusters. So you're really cutting down the impedance mismatch between your different environments, essentially, over there. Now, a lot of time customers, what they do is they customize the Docker image, the tag, et cetera, that they want to play around, because my database environment is different and my test and staging environments are different. So all those capabilities do very much exist. But the point being, you literally just switch the cluster and redeploy the application. Another tool that I've seen customers using is by Heptio, and it's called as an Arc. So if you look at Arc, this tool is very useful. It is typically meant for managing your disaster recovery. But essentially, what it does, it takes a backup of your Kubernetes cluster. You can take a backup, and then you can restore it on a different cluster. So it's very handy. Essentially, if you think about the Kubernetes architecture, it has a whole bunch of stateless components, like my service, my deployments, but all of that state is still stored in etcd, which is my backend database, essentially. So what Arc does is, it automatically takes a backup of your etcd and restores it in a new cluster. So that's another way we have seen customers kind of migrating between different environments, essentially. So once again, I've shown here how you can migrate from dev to prod. You can check the list of pods. Your application is up and running. So what I can do is now I can say, if I say Helm list, I have Helm already installed on the EKS cluster. It says, yep, all it has is Istio system install. So now I can say Helm install. The exact same application is now getting deployed on my EKS cluster running on AWS. So if I say kubectl get service and deployments, and it's showing me my service and deployments. It is showing a whole bunch of others as well. But then I can say /label name equals greeting. Oh, actually, deployments only have that label. Oh, app greeting, you bet. Yeah, the label, depending upon if you're deploying it as a Helm chart, the label could be a bit different. So if what we can do is kubectl describe deployments my app greeting. And if we go up here, labels is, oh, see, chart equals app. That's the one it has created. Release app. It has a different set of labels here. Oh, there you go. Oh, app equals my app : greeting here. So, or we wouldn't dig into much into it. But the key part is now, because I said type colon load balancer, in this case, it's going to create an ELB. ELB takes about 2 to 3 minutes to be provisioned and ready to be used. But essentially, once it's deployed, the exact same application is now accessible on my Elastic Load Balancer here. Okay. So let's switch gears. We talked about sort of my Docker, Java application, Docker image, Kubernetes Helm, deploying it into a cluster, migrating across clusters. Now, what I want to do is I want to be able to create a new version of my application. How do I bring that new version of the application into the cluster? How do I do my canary testing? How do I do my A/B testing over there? And when I'm doing canary testing, I want to direct only 5% of the traffic to my new version, not a whole lot. Well, that's where the concept of service mesh comes in handy. And the most popular service mesh is essentially Istio today that we see a lot of our customers using. And the way Istio works is it really relies upon the concept of a sidecar. Remember we talked about that in a pod, there is a single container is there. It can have one or more containers. So in my pod, there is one application container. And what I do is, as each pod is getting created, I could inject a sidecar container to it. And that sidecar container for Istio is basically used on Envoy. Envoy is a CNCF project, and it was contributed by Lyft. So Lyft has been using Envoy for a while, and they're able to do up to 2 million concurrent requests per second, essentially using Envoy. And that's the capability and the scale it brings. It's about a very small memory footprint, written in C++, so it doesn't add a huge overload. But essentially, imagine each pod in your cluster that is getting created, it has an Envoy sidecar injected. Okay? Now, the container in a pod can talk to each other because they share the network, file system, all of that. They can talk to each other using localhost. So now imagine there is a greeting service and there is a name service. They want to talk to each other. They don't talk to each other directly. They talk to their Envoy proxy. The Envoy proxies then figure out who they need to talk to, and then these services talk to each other like that. So imagine all the network traffic in the Kubernetes cluster, for your application at least, is going through the Envoy proxy. And the fact that it's going through Envoy proxy allows you to do a lot of magic over there. Imagine if you were to do a canary deployment. How do people typically do canary deployment in Kubernetes without service mesh? Well, they have a deployment. They scale the deployment. There are 10 replicas in the deployment. Now, let's say you want to have another deployment over there, and in that deployment, you want to guide only 5% of the traffic. Well, the minimum number of replicas I can have is 1. But this is 10, so that makes it at least 10%. So I don't have that granularity. So I need to really make it 20 and keep this 1 to bring 5% of the traffic. So it's not very efficient way. And that's exactly where Envoy kind of fits in very well. Because all we are doing is, because all the traffic is going through Envoy, I can literally start creating traffic shifting patterns within my Kubernetes cluster very easily. So let me quickly walk you through one of those files over here. So essentially what we do is, so once I have Istio installed into my Kubernetes cluster, it's a service mesh. So basically you download the Istio toolkit, and then you install Istio into Kubernetes cluster. Now the Kubernetes cluster recognizes different Istio components that can be created. So for example, in this case, I'm creating a virtual service. I'm creating a destination rule. And in the virtual service, what I'm saying is, here's a greeting virtual service that is taking greeting hosts. And I want to be able to guide traffic to greeting hello. And I have a new service which is saying greeting howdy. And I want to guide 75% traffic to greeting hello and 25% traffic to greeting howdy. How are greeting hello and howdy defined? They are defined in the destination rule. And those are defined using greeting colon hello label and greeting colon howdy. So now imagine you can keep deploying your applications. Just change the labels on them accordingly, and accordingly create the right virtual service and destination rules to alter how much traffic needs to be shifted between different applications. So that's one use case. That's typically the most common use case for a service mesh. There are a lot of other things that you can do over here. So we talk about traffic shifting, how that works. And you can do canary deployment, how that works. Istio also comes with distributed tracing. If your apps are using multiple languages, using different Docker images, you can enable distributed tracing across all of these different apps. It's completely language agnostic in that sense. You can also start injecting faults in your application. Talking about chaos engineering using Kubernetes is a full topic by its own, so I won't dig into the details. But essentially, if you look at the timeout section, it talks about how can you inject like HTTP 404 or 500 or timeouts into your application to make your applications more resilient. So that's, again, a huge benefit of Istio. And the last part that I quickly want to talk about here, like last 30 seconds, is how easy it is to create your deployment pipelines. So, well, of course, we use Jenkins. So there is a project by the company CloudBees called as Jenkins-X. And I particularly love that project because Jenkins-X makes Java applications, well, any Kubernetes applications, and it brings Kubernetes to them in a very cloud-native way. So that's definitely a tool that you want to look at. The other tool that I use actively on my day-to-day development is Scaffold. That's by Google Container Tools team. And it basically allows you, every time I make a change into my code repository, if I save it, it'll automatically build my Docker image, update my Kubernetes artifacts, and deploy it to my Kubernetes cluster. So I would recommend taking a look at that. All the code, as I said, is still on the GitHub repo. I would love for you to file issues, send me pull requests, or tell me what else you would like to see over here. I'm going to be at the conference for the next few hours if you want to talk to me, or come find me at the AWS booth. Thank you so much.